Let's take a look at one more example. I'd like to rewrite f at x equals negative x squared plus 6x minus 2 in vertex form using completing the square. So step 1, we'll write down our function, negative x squared plus 6x minus 2, and I'm going to move the negative 2 out to the right just to move it out of my way for a few minutes. So you'll see that I did that in the next step. Now, I'd like to factor out the negative 1 from the first two terms. Remember, I will not factor it out from the third term, so I'm only going to take the negative 1 out of those two terms. When I do that, that leaves me with negative 1 multiplied by x squared minus 6x, and I'm going to leave a little bit of space before I close my parentheses, and then I still have the negative 2, or the subtract 2. So again, remember when we factor out the negative, both signs will change from the items that I've now put in the parentheses. Now I complete the square on the first two terms of the expression. Those are the ones inside the parentheses. So we take half the coefficient of the x term and square it. So half of negative 6 is 3, negative 3, squared gives us 9. And as we've done before, what we will now do is place that 9 inside of the parentheses. Now when I do that, the net effect was not an addition of 9. The net effect was actually a change of negative 9. So in order to make sure that that right-hand side is unchanged, that I maintain the appropriate balance, I have to do the opposite of that, and so I will add 9. So notice that I put the plus 9 in the parentheses, but the effect when I multiply by the negative 1 is negative 9, so I add 9. So that leaves me with negative 1 multiplied by the quantity x squared minus 6x plus 9, and then plus 7. Now if I factor those first three terms, I have x minus 3, quantity squared, in the parentheses, and so my final answer is negative 1 multiplied by x minus 3 squared plus 7. From that, if I wanted to, I could read off the vertex. And so if I did that, the vertex would be 3, 7. The axis of symmetry would be x equals 3. And I would notice that because I have the negative out in front, this is a parabola that opens down. And if I wanted to, knowing that the vertex is 3, 7, and if I went back to the original problem, I would notice that, that my y-intercept was negative 2, I could draw a reasonably decent graph of this particular function.